In the previous video, we looked at motion in one dimension. Now we will look at motion in 2 or 3 dimensions. When doing so, we have to consider vectors. The motion of an object in 2 or 3 dimensions is related to its position vector, r, where r is shown as unit vectors. Unit vectors give the component of r in the x, y, and z directions. And we know they're unit vectors because we use a caret over the letter instead of the arrow. As an object moves, its displacement is given by delta r, which is equal to r2 minus r1, which in terms of unit vectors would be x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. The velocity vector, which is the derivative of r with respect to t, would be given as dx dt I plus dy dt j plus dz dt k, or shown as vxi plus vyj plus vzk. Similarly, the acceleration vector, which is a derivative with respect to time of velocity, would be equal to dvx dt I plus dvy dt j plus dvz dt k. And that can be shown as axi plus ayj plus azk. We can integrate acceleration to find velocity and velocity to find r as follows. The integral of a dt is equal to v, and the integral of v dt is equal to r. Let's look at a vector r in 2 dimensions. If we draw that out, we have our x and y dimensions. Here's our vector r. And r has a component in both the x and y direction. That would be rx and ry. So the value of r is actually equal to rx I plus ry j. And from the Pythagorean theorem, we know that r squared is equal to rx squared plus ry squared, or the magnitude of r is the square root of rx squared plus ry squared. We also know that if this is the angle theta with the x-axis, that rx is equal to r cosine theta and ry is equal to r sine theta. And we also know that tan of theta is equal to ry over rx. Let's do some problems. The position of a car is given by its vector r, where r equals 2t to the 4th I minus 4t to the 3rd j. What is its velocity at t equals 3 seconds? What is its acceleration at t equals 5 seconds? So we're given its position vector r, which is equal to 2t to the 4th I minus 4t to the 3rd j. We know velocity is the derivative of r with respect to t. So let's do that. So we get 4 times 2t to the third I minus 3 times 4t to the 2j. And that's equal to 8t cubed minus 12t squared. We'll put the I and the j in. So at 3 seconds, we get velocity is equal to 8 times 3 cubed I minus 12 times 3 squared j, which ends up being 216I minus 108j. So that would be our velocity. For part B, the acceleration at 5 seconds, we know that acceleration is equal to the derivative of velocity with respect to time. And what we're going to use is, if we go back up here, we're going to use this equation for velocity. So if we do that one, we get the derivative of that is 3 times 8t squared I minus 2 times 12tj, which is equal to 24t squared I minus 24tj. And at t equals 5 seconds, we get 24 times 5 squared I minus 24 times 5j. So our acceleration ends up being 600 I minus 120j. And those are our answers. Let's do another problem. A plane's velocity is given by v equals 8t cubed I minus 9t squared j. What is its displacement from 0 to 3 seconds? What is its acceleration at t equals 6 seconds? So for part A, we're looking for its displacement, or delta r. Well, we have velocity, and we know that r is the integral of velocity. So let's integrate. So delta r is equal to integral of v dt from 0 to 3 seconds, which would be the integral 0 to 3 of 8t cubed I minus 9t squared j dt. And so we'll do that, and we get 8t 4 over 4 from 0 to 3I minus 9t cubed over 3 from 0 to 3j, which gives us 2t to the fourth from 0 to 3I minus 3t cubed from 0 to 3j. And we know when t equals 0, these terms become 0, so we can just solve for t equals 3. So at t equals 3, delta r is equal to 2 times 3 to the fourth I minus 3 times 3 cubed j, which is equal to 162I minus 81j. So that's our displacement. For part B, we're looking for the acceleration at 6 seconds. Well, we know acceleration is the derivative of velocity, so that would be d dt of our velocity vector, which is 8t cubed I minus 9t squared j. That would equal 3 times 8t squared I minus 9 times 2tj, which is equal to 24t squared I minus 18tj. So at t equals 6 seconds, we get acceleration is equal to 24 times 6 squared I minus 18 times 6j, which becomes 804I minus 108j. Let's do a third problem. An object moving in the xy plane has velocities given by vx equals 6 plus 2t and vy equals 4 plus t. Show the velocity as unit vectors. Find x and y as a function of time. Assume the object starts at the origin. What is the acceleration in unit vectors? And what is the magnitude and direction of the acceleration? So for part A, we can write Vx is 6 plus 2t and Vy is 4 plus t. So our vector comes to 6 plus 2ti plus 4 plus tj. And that is our vector in terms of unit vectors. For part B, find x and y as a function of time. Well, to find x and y as a function of time, we need to integrate v, the velocities. So x is equal to the integral of vx dt, which would be the integral of 6 plus 2t dt, which is equal to 6t plus t squared plus a constant. Well, we know at the origin t equals 0 and x equals 0. If we plug that in here, we find that c equals 0, and we get x is equal to simply 6t plus t squared. Likewise, y is equal to the integral of vy dt, which is equal to the integral of 4 plus t dt, which is equal to 4t plus 1/2 t squared plus c. Again, at t equals 0 and x equals 0, y equals 0, we find that c equals 0, and y becomes 4t plus 1/2 t squared. In part C, we want to know what the acceleration is in terms of unit vectors. Well, we know acceleration is the derivative of the velocity. So acceleration is equal to dv dt, which in this case is d dt of 6 plus 2ti plus 4 plus tj. And if we go through that, we get 2i plus j. So that's our acceleration in terms of unit vectors. In part D, we want to know what the magnitude of the acceleration is, as well as the direction or angle of that acceleration. So we know that the magnitude of acceleration is equal to the square root of ax squared plus ay squared. And in this case, ax is 2 and ay is 1. So that's equal to the square root of 2 squared plus 1 squared, which is the square root of 5. We also want to know what the direction or angle with the x-axis the acceleration is. Well, we know that tan theta is equal to AY over AX, which in this case is equal to 1 over 2. And using the arctan, we will find that we get an angle of theta equal to 26.6 degrees. Let's do our last problem. Two objects are thrown horizontally in opposite directions at a height h above the ground with velocities of v1 and v2. What time will the velocity vectors be perpendicular to each other, and at what distance apart will they be? So let's make a little diagram of this. So here is our objects being thrown. This is velocity v1 in the x direction, velocity v2 in the x direction, and we're going to use our axes as x and y. Height h above the ground. And we want to know at what point will these vectors be perpendicular, the time when perpendicular, and we want to know the distance r1, 2, how far apart they are when perpendicular. So let's see what we have here. Well, we know our velocity 1 is equal to v1x plus v1y, which is equal to v1xi minus gtj. And our velocity 2 is equal to v2x plus v2y, which is equal to a minus v2xi, and it's minus because it's going in a negative x direction, and also a gtj. So we want to know at what time are these vectors perpendicular to each other. Well, for two vectors to be perpendicular to each other, their dot products have to equal 0. So v1 dot v2 must equal 0 when they're perpendicular. So let's go over dot products of vectors. If you have two vectors a and b, the dot product of these two vectors is equal to ax times bx plus ay times by, and that equals 0 when they're perpendicular. So for our vectors v1 and v2, the dot product of v1 and v2 is equal to v1xi minus gtj dot minus v2xi minus gtj, and that becomes minus v1x v2x plus g squared t squared, and if you solve for t equals the square root of v1x v2x over g. Now we want to find how far apart these vectors are when they are perpendicular. So we're looking for the vector r12, which would be equal to the magnitude of r1 minus r2, which in this case would be vx1 times time plus vx2 times time. or Vx1 plus Vx2 times time. Well, we know t from above. If we substitute that in, we find that R12 is equal to Vx1 plus Vx2 times the square root of Vx1 times Vx2 over G. And that's the solution to this problem.